Did you know this video knowledge is
over 9,000?
Yeah.
In Le Chatelier's principle, it states that if a system experiences stress, then that system will change to relieve that stress. Now, this causes an equilibrium to shift towards either side. There are three stresses that we will be discussing today: change in temperature, change in pressure, and change in concentration. In an equilibrium, the rate of production from reactants to products, and vice versa, products to reactants, are the same. But when that balance is disrupted, you turn to Le Chatelier's principle.
When it comes to temperature, in this case, this reaction requires heat. And if I increase the temperature, therefore increasing this heat, the reactants are favored and the forward reaction is faster. If I decrease the temperature, the products are favored and the backwards rate is faster. Let's move on to pressure. Changing pressure affects gases. When we are increasing the pressure in this example, the reactants are favored because of the greater amount of molecules of the reactants can easily make more of the products. Therefore, the forward rate is faster than the backwards rate. When you increase the pressure, the forward rate is faster and the products are easily more made. But after a while, the rate of the backwards reaction will increase, and that will eventually reestablish equilibrium, but also the pressure will try to get a little bit more back towards the beginning pressure before there was a change. The reason for that is these less molecules make less pressure, so it's counteracting the increased pressure with a little bit of less pressure. When it comes to concentration, increasing the concentration of reactants, the reactants are favored and the direction of shift is from reactants to products. This rate is faster, whereas this rate is slower. If I were to increase the concentration of hurt students, then the rate of getting bullies will be faster than bullies turning into hurt students. If I were to increase the concentration of the products, then the products are favored and the shift is from P to R. After changing concentration, how does equilibrium reestablish? Well, if the reactants have a higher concentration, then the forward rate is faster than the backwards rate.
Hey Teddy, how do you know whether the products or reactants are favored in a reaction?
I use the equilibrium constant, which is the ratio of product concentration to reactant concentration.
What are the brackets for?
The brackets inside is what the concentration of the products are.
Okay.
The exponents is the moles of the substance. They're the coefficients in a balanced chemical equation. And this formula helps us out with understanding which side of the reaction is favored. If it is greater than 1, the products are favored. If it is less than 1, the reactants are favored. Before we start anything, we have to make sure this is balanced. And in this case, it is. So let's move on to determining the concentration. The concentration of the reactants is 0.0045 moles per liters. And the concentration of the products is 0.030 moles per liters. Plug that into the formula. Products over reactants. Coefficient is the exponent. Concentrations, you get it. Then simplify, and 0.20 is the answer. The answer is less than 1, therefore the products are favored.
This is Mr. Lindsay, and I approve this message.